Yes. So today we'll discuss the pointer. So in the session we'll discuss how can I define a pointer, how the pointers works, and before we start the pointer, let us have a let us have a little discussion about the data types and the array that we already uh, gone through. So something that we want to understand is that if we declare an variable like integer or character, then we are basically referring the value of the variable by its name. And whenever the variable is appearing at the left hand side of an assignment statement, then we are basically referring to the address of the variable. So it looks something like this. Let me work here. So say I declared an integer a. Okay. Then what is happening in the memory? In the memory, compiler reserves a area or compiler reserves some memory, and this memory is now referred by the name of the variable a. Okay, understand? So it is maybe a four bytes, as a is an integer, so compiler may allocates 4 bytes for the variable a. Okay. Now when I have a statement like a equals to 10, this is one statement, and there may be another statement where say we have another variable like b equals to 10 into a. Okay. Then what is happening in the compiler, how these two statements are referred in the C programming language. The first thing is that whenever there is an assignment statement, so this operator is called the assignment. That means we are assigning the value to a variable. So there is a value and there is a storage. Okay. So I am putting some things in a container. So this container is now A. Okay. So the meaning is that whenever the variable is appearing at the left hand side of an assignment statement, then they are basically referring to this address. So they are basically referring to the to this area. So which is logically termed as a A. Okay. So the first statement says that when I am appearing, I am writing a variable name at the right hand side of an left hand side of an assignment, then it is basically referring to the address of a. Yeah. And there I am placing the value of 10. Whereas when the variable is appearing at the right hand side of an assignment statement, say I am writing 10 into a. Okay. Then I am basically referring to the value of the a. Means in this case I am picking the compiler is taking the value of the element which is stored in this area, and then it computes the operation, and a new value comes which will be assigned to a variable b. Yeah. So this says that it is basically referring the value of a. Okay. So whenever we declare a simple variable a, that means it has two types of implication. Either I am fetching the value from the variable a, or I am putting something into the variable a. So when I am putting something into the variable a, then a appears at the right hand left hand side of the assignment statement. Or whenever I am fetching the value of the variable a, then a appears at the right hand side of the uh, assignment statement. Okay. Okay. So so there are two types of data declaration that we have already encountered. One is called the variable a, and this basically an array of the variables. So integer a is basically a declaration of the data type a as an integer, and integer array within box bracket 10 declares a continuous array or the linear array of an integer of size 10. Okay. Then what is the difference between the two declarations? How the compiler or how a programmer can distinguish the two declarations? The first thing is that whenever I declare an integer, so it says that it is basically allocating a 4 bytes of memory in the computer memory. So 4 bytes comes from the size of the integer. It depends on the compiler. It may be 4 or it may be a 2. So whatever the parts, but it allocates a 4 bytes of storage in the memory. Means it is reserving. So throughout the program, whenever I encounter the symbol of the variable a, it is basically referring to this allocation. Understand? And the second thing says that it is basically reserving or allocating a 10 consecutive bytes. The 10 consecutive bytes in the sense that if we have an integer array a and integer say a 10. Okay. So in this case, it will randomly allocate some space for 4 bytes. Okay. So this is symbolically named as A, and this allocation may be done by random. It does not start from the begin of the memory. It allocates a memory space and of size 4 or maybe 2, depends on the size of the integer, something like this. But whenever we declare that array, then it does the same things, but instead of allocating a 4 bytes, it will allocate consecutive 10 such 4 bytes. Understand? So there will be 10 such allocations. So this is the begin of this A, and then we have the 0th, then 1, then 2, dot, 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 and the 9th. So all these things are size 4. Clear? Understand? And this starting part means we call these things as the base. So this is the base address. Base address. And this base address is randomly picked by the compiler. So it is not always the begin of the memory. It is randomly picked by the compiler, but once it is fixed, then there will be 10 consecutive allocations. Each allocation will have the 4 bytes. Understand? So that is the first difference. Then how do we interpret? That is already we understand. If it is an integer, we interpret this as a sign 2's complement binary representations. Similarly, if in an array, if we have declared an integer, then every cells are interpreted. So every cells means we call these things as cell. Every cell are interpreted as an integer, and then we have a continuous allocation. Means the thing is that we can index the first allocation by something like this, the second allocation something like this. In this way, the last allocation is A9. Okay. So there are two types of interpretation. The first is that how the cell elements are interpreted. They are interpreted as the declaration of the variable. If it is an integer, then interpretation will be an integer. If it is a character, the interpretation will be a character. And the second is that the consecutive sequence can be indexed. It may be indexed by 0, 1, 2, 3 up to n minus 1, as the size is basically 10. So we have 0, 1, 2, 3 up to 9. Okay. So what we get that in an array there is a base address, which implies or which indicates the starting address or starting point of the array. Okay, understand? Okay, so secondly, that what are the operators that we can perform on that integer? So we understand that there is a set of operations that can be performed on an integer a. But on the other hand, what are the operators that we can perform on that array base address? So in this case, whenever there are two declarations. One is that integer a and integer say a. If we don't want to make any confusion, let it be array. Let it be array, something like this. Otherwise, there may be a confusion. Okay. So there is another declaration array of 10. Okay. Now the thing is that when we are stating that in the program, I write an a either in the left hand side of an assignment or in the right hand side of an assignment, then I can perform some operation with this thing. Say a plus say 10 or some things, a or b. So these are the operations that we are applying on the integer. Yeah, so a becomes the integer, then we have a set of operations that can be performed on the integer. But the thing is something different when we refer to an ARR. Yeah, then what are the operations that I can perform on these things? So the meaning is that when integer a is declared, then a is considered as a data type of integer. But whenever integer a array is declared, then array ARR, this variable is not a data type. This variable is basically a data structure. What do you mean by the data structure? Is organization of the data. So an array gives you an organization of the data of homogeneous type. Means if it is an integer, then the organization will be all integers. Yeah. So it does not give you a data type. So I don't have some operations like array into 2. I cannot perform this type of operations. This is not allowed. Yeah. Understand? So I cannot perform array divided by say 5. So this is not allowed. These parts are not allowed. So we don't have a data type as an array. Array is basically a data structure, but it provides some facilities. So some limited number of operations it provides. So what are the operations? I can perform some offset of operation. So offset is basically, say if it is an array, say this is the memory, and it starts with the base address here. Clear? And we have subsequent allocations. Say this is the 0th, this is 1, this is 2, this is 3. Then offset means that I can perform the base address to be moved from the initial point to some another starting point of the cell. So if I write array plus 1, that means I am putting an offset of the base address by 1. So ARR is pointing to the starting point of the array. ARR plus is basically pointing to the starting of the second element. ARR2 is basically pointing to the third element of the cell. Understand? So we say that this operation, this plus, when we apply these things with an array, it is basically an offset. Understand? Clear? Get it? You understand this point?
Yes, sir.
Okay. So basically what we say that whenever we declare an array, so like int ARR, say 10. Now ARR is not an integer. This is not integer. Yeah. It is basically an starting point. It is called the base address. That is, it is looked like an address, and this address is the starting point of the integer, a starting point of the array. Understand? So whenever I refer to an a double r, I am not referring any integer type of data. I am referring the starting point of an allocation, and this allocation will having integer type of data. Understand? Yeah. And then we find that we have limited number of operations. I can only do addition or subtraction, which is basically an offset. Addition is a positive offset. Subtraction is basically a negative offset. Then I can do some conditional operation. I can check that whether the base addresses are equal or not, whether the base two array, their base addresses are equal or not. That I can check. Okay? And I can also do some logic operation. The logic operation says that whether the base address is void or the base address is legal or not, that I can check. Okay? So I will discuss these things later on. And the indexing operation. The indexing operation is basically a binary operation. It is a special operation which is defined in the C. So this operation is called an index operation. Okay. And the index operation is binary. So we have left hand side, we have a base address, and then we have the operator, and inside we have the index. Okay. So if I write ARR, say 1, that means in my allocation, I have the base address starting from ARR, and this is the index 0, ARR 0. This is basically the index 1, RR plus 1, which is also equivalent to ARR 1. Then we have array offset 2, and this is equivalent to array of 2. Yeah, understand? So what is the difference between the left hand side and the right hand side? The left hand side is basically the addresses. The right hand side basically the element. Sorry, these are the elements. Whatever. These are the elements. Understand? So whenever I write, I am applying the offset ARR plus say 2. I am basically referring the address. So this is ARR 0. This is ARR 1. This one is ARR 2. So ARR 2 is basically referring this address. And ARR index 2 is basically referring the element stored in that address. Okay? Understand? Yeah. So it looks like, say, I have some boxes in a linear way. So if I say the third box here, so that is equal to ARR plus 2. But if I say that the content in the third box, the content in third box, this is basically ARR2. Understand? Clear? So this is the content and this is the address. Okay. You get this point?
Yes, sir.
Oh.
Yes, sir.
So these are the differences. Whenever you declare an array, and then declaration of the array is, you understand. Okay. So then what is happening? The name of this array is not basically a data type. It is basically a declaration of a data structure. But when we refer the name of this array in my program, we are basically referring the base address of this array. Understand? So this is already, you understand that this the variable array refers to the base address of the data structure that we call the array. So array does not have any operations in such, but C programming allows some operations, a limited number of operations, and they have their meaning. Like plus operation is basically the offset operation. Then the box bracket operation is the index operation. Okay? The second thing is that whenever we declare an array, then this declaration is basically a static allocation. What do we mean by the static allocation? Say I declared an integer array 10, then compiler allocates 10 consecutive cells for this base address. So there is a array base address, and once these things is allocated, and then this allocation becomes a static allocation. Okay, that means this becomes a constant. So I cannot reuse this address by assigning some different value. Means, so this total address cannot be moved in some another memory location. So I cannot move the whole content in some another memory location here. So this type of statement like array is something moves to array 2. That means I am the whole array 2. There is an array 2 which is also present in the memory. This whole array 2 cannot be moved here. Understand? So all the array declaration becomes a static allocation. You understand this point?
Sir, please repeat this point.
Okay, let me draw a little bit clearly. So say I have two declarations. One is int array 1, which is 10, int array 2, which is also 10. So like now in my memory, the compiler will allocate say 10 consecutive cells, and the base address is array 1. Okay? And it will also does the same things for array 2. Okay? So there will be 10 integers continuously. There will be also 10 integers continuously. Okay? Now, as they are variables, so if they are variables like integers, integer a1, integer a2, so what we basically have this type of statement a2. That means there is a a1 in my memory, sorry, a1, there is a a2 in my memory. So some data is stored here, some data is stored here. This statement is basically what it does. It fetch the value 20 here, and it puts the 20 in this location. Understand? This is basically what we mean by the assignment operation. But in case of array, let me delete this part. In case of array, what is the meaning of this statement? Say ARR1 is equals to ARR2. Okay. So both are addresses. So this is the base address, This is also a base address. That means I am reassigning. I want to reassign this base address with the value of this array 2. So that means I want to shift. I want to shift all this content. I want to make all these contents available in this area. Understand? Is that true?
Yes.
Oh, and then this thing is not possible. This thing is not allowed in C. The meaning is that they are static. This allocation becomes a static. Yeah. So whatever the base address is assigned to array 1 will remain constant throughout your program. So your base address cannot be changed, or you as a programmer cannot change the base address of an array. So once the base address is assigned by the compiler, it will remain constant throughout your program. Understand? So I cannot make a statement where I try to override the base address of an array. That operation will be an illegal operation. Understand? Get it?
Yes.
So we say that array is not a data type. We do not have a meaningful statement in C like the one array is assigned to another array. So I cannot make a array 2 assigned to a base address of array 1. So this declaration will be invalid. Similarly, the multiplication operation is not defined. We have the addition and the subtraction, which are termed as an offset. Yeah. So we don't have multiplication, division, or say exponentiation operation. They are not available in the in this array. Okay. And the other part is that array is basically whenever we access, whenever we want to write, whenever we want to access the base address, then I can get the base address of the array by the name of this array. Means whenever I write ARR, it basically returns me the base address of the array. So these 3 points are important. They are different from the declaration of an integer. Yeah. So keep in mind that whenever I declare integer A, then I am basically defining an data type. So we have the allocation, we have the memory, we have the allocation, we have the operator. Whenever we declare an array, we don't declare any data type. We are declaring a base address which will having some number of homogeneous elements. Understand? Yeah. Get it? Okay, so this is basically what we have already discussed. So declaring an integer A is basically it allocates a space in the memory. There are 4 bytes which is reserved for the declaration of A. Declaration of B also does something like this. And then the operator, say A assigns to B, is basically I am fetching the value of A and putting these things into the B. So this is basically what is shown in this figure. I am basically putting the value into the A, but at the same time the value A is also remaining. So in this figure the whole content is shifted to B. This is not true in C programming language. The value of A remains unchanged. The value of B become updated by the value of A. Understand? Is okay?
Yes, sir.
Yes, sir.
And now the array is something looks like. Array is basically when we declare an array, then this is basically the base address. So the compiler does these things in his own. So I don't have any control. The programmer does not have any control over the base address. So the base address is assigned by the compiler, and it is during the compilation or during the execution of the program. Understand? So it assigns the base address. Then we have continuous and continuous locations. So if it is a size of 10, then say 563 plus 4 bytes is basically 540. Then this 540 is the base address of the second element. Similarly, 544 is the base address of the third element. Okay? So in this way, the continuous allocations will be taken care. Okay. So if I give you the base address of the array and I say that integers are 4 byte, then you can compute the ith address of the element. Okay. Get it? Is that clear?
Yes, sir.
And secondly, these two operations are different. The two operations like A are array plus say 3 and array index 3, they are different. So this returns the element, this returns the address. Okay, understand? So this is basically what we already explained. Is basically the array2 is the base address of the third element. So it starts from array 0, array 1, array 2. So so the first element, if it is stored in the memory location of here, then the array 2 is basically 4 into 2 plus the base address. The 4 is the size of the integer, so 4 into 2 plus the base address. Clear? And then array index 2 is basically the element which is stored in that memory location. Okay. So okay. Now we come a different representation of the address. So we understand what the address signifies. So address signifies that the starting point of a data representation. If it is an integer, then I can have a location where the integer is stored. If it is a character, I have a location where the character is stored. So integer is something like this. Then characters are something like this. Yeah. Then float have a representation something like this. Yeah. So there may be a 4 bytes, character may be a 1 byte, then this may be a 4 bytes, but we always have the base address of this part. Yeah. So we understand that what the address signifies. Address basically signifies that from where the element is means from where the element is stored. Yeah. And then we have to interpret the content by their data type. Okay. So if it is an integer, I interpret the content by using 2's complement. If it is a ASCII, then I interpret this content using the if it is a character, then I interpret the content using the ASCII code. Okay. So address is basically where I get some idea about the address. Okay. Now C will provide you data type which will directly works with the address. Okay. So far what we are working on the data. So data is basically the container, the item on the container. Okay. Now C will also provide you to handle with the container itself. Okay. If we have a dish or if we have a box, then so far what we have done is basically what is inside the box. But now I am able to handle the box itself. So I can able to make some logic or make some operations on the address itself. Yeah. So C, first we try to understand that how can I declare the pointer. So pointer is basically in C or C++ language, whatever the part. In C, the pointer is a data type. Pointer is a data type. Okay, and it represents the address. Okay, understand? So now the thing is that what address it is representing. So if I declared the statement say int star IP, So then IP is the variable. IP is the variable. Okay. Then this variable is pointing, or this variable is referred to an address of an integer. Okay. Understand? So take a note that this is basically, say, IP. If I write something like this, then what is the meaning of these things? It says that IP is an integer variable. Okay. Now, if I write integer star IP, then it says that IP is basically a address where I can store a pointer. Sorry, where I can store an integer. Understand? Yeah. Get it? So it looks something like this. Say I have declared integer pointer, and I also have a, say, A. So in the memory, it looks something like this. Say this is the base address. Let it be 437,516, where I have and this represents the A. Say something 50 is there. Okay. Then I also have a variable which is available in the memory, and this is called integer pointer. And this integer pointer does not contains the value. It basically contains the address. So it may contains 437,516. That means it is this, whatever is present in the IP is basically pointing an address where an integer is present. Understand? So what IP holds is an address where an integer data is present. Understand? Do you get this point?
Yes, sir.
Shall I repeat these things?
Sir,
Yes.
can pointer holds the address of long type integer or only integer type data type?
No, it can hold anything. It means whatever the data types are available, like integer, long, short, then float, character, whatever the. We also have their corresponding pointers. Understand? So let me just give you this slide. So this is saying that integer pointer. That means IP is holding an address where an integer can be stored. Then float pointer. So it says that FP is holding an address where a float data is stored. Understand? Similarly, character, similarly short, then long, double, all these things are possible. Understand? Okay.
Okay, sir.
Means for every data type that I can declare in C, their pointers are also valid. Okay. The void pointer will declare, we'll discuss these things later on. But working with the basic data types, the thing is something like this. Say I declared a counter. So in this example, there is a main, and in the main I declared a integer counter. So this is the counter which is stored in the base address, say 536. Yeah. And I declared a pointer to an integer. So integer star IP is basically a pointer to an integer. Yeah. And then count is holding the value of 10, and then this ampersand count, yeah, is assigned to the IP. Yeah. So previously what I have seen that base address cannot be reassigned. Base address of the things are always constant, static. Now this pointer is not a static item. pointer can be data type, so it can be reassigned. Understand? So array as a base address cannot be reassigned, but pointer I can do these things. So what I am doing, I am now assigning the pointer with the base address of the count. Understand? So ampersand count is basically a unary operator which returns the base address of the data. Clear? So base address of the data means this value is now stored in the variable IP. Okay? So the meaning is that now IP is pointing to a base address where the variable count is stored. Understand?
सर काउंट 10 का क्या करना है यहाँ पे?
नहीं, count 10 का कुछ नहीं करना है, but we'll show which how can I do these things. But the scenario is something like this, that this statement is basically assigning the pointer with the base address of the variable count. Understand?
Okay, sir.
Okay. So now it is now you can understand that what we are writing in the scanf. Scanf, what we are doing? We are basically writing something, say D, say A, where A is an integer, say integer A. Okay.
Sir, and A, I think.
I am writing these things. So what is the meaning of these things? The meaning, it says that I am assigning a variable, clear, where I have to put the scan value. So I have to read something from the keyboard and I have to put these things in the container. Okay? The container will never be referred by the A. A is basically the variable. Okay? But I am to refer the container, I have to refer the base address of this thing. And this is basically the ampersand A. Okay? So unless I don't write an ampersand here, sorry, this ampersand, whatever the ampersand. Ampersand A. So ampersand A is basically returning the base address. So this, whatever I am writing in the scanf, I am basically putting the second argument. So this is the first argument and this is the second argument. The second argument is basically the base address of some container. I am not fetching the container. I am fetching the base address of the container. Understand? Get it? So scanf is saying that, okay, I will read something from the keyboard that is in this argument. Then where I have to put these things? I have to put these things in a base address, and base address will be the operator ampersand. It is unary. UNRI. What is the meaning? It is unary operator, and it may be an integer, say A. It may be integer. It may be character. It may be float or any other types. But this will return you the base address of the variable. Understand? Okay. Okay.
Okay, sir.
Yes, sir.
So this is what I am saying. Now I am able to reassign. I am able to reassign IP variable with the base address of some integer. Yeah. Okay. So every time we will have these things. The assignment should be compatible. Means if I have a float as a counter, then float as a pointer, then I can do these things. Yeah. Okay. So this is basically the interpretation of these things. Here, integer IP is declared as a integer pointer, and this statement IP equals to base address of count is basically assign the address of the count to the IP. Yeah. Okay. So now what do we understand? We understand that IP is not an integer. Clear? This is very clear. IP is not an integer. IP is basically an address where an integer is stored. So it is basically a pointer to an integer. So in short, we call these things pointer to an integer. pointer to a character, pointer to a float, something like that. Okay. So this is the statement that we use to refer or use to define. The thing is that the variable IP holds the address of the counter, so it does not hold the content of the counter. Understand? So it will holds the address of the counter. Okay. Then what are the operators? So as this is an integer, pointer is a data type, so it must have some operations. So there are some operations which are also defined on the pointer. Understand? Yeah. So so whatever we have understand is that what pointer means. Okay. Then we have to understand what a pointer operates, how a pointer operates. Okay. So, okay, we can. This is around 11. So I have another class from 12. So I can stop for today. So next class we will discuss how the operator will be how can we do the operation on the operators, pointers. Understand? Yeah.
Okay, sir.
Okay, sir.
Okay. Thank you. Any doubt? If you have any question?
Thank you, sir. Sir, what is the syllabus of CSC01 midterm?
Huh? Syllabus. Oh, syllabus.
Yes, sir.
We'll declare, means there is a common. This is the common subject. We have a meeting on 9th. So after 9th, we'll declare the syllabus and the modality of the exam. Okay.
Okay, sir. Thank you, sir.
So,
Thank you, sir.
Thank you, sir.
Thank you, sir.
yes.